Hello everyone. My wireless communication project title is Handoff and Channel Estimation in a Cellular Communication System. Here it is simple model of cellular communication system, which consists of cells with base stations. Look at this hexagon-shaped step here. They are all cells. Data is transmitted over a sequence of time slots from one cell to the other. And cells can be sized in different situations. This is the basic model of handoff, or an important attribute of cellular communication. As it shows, with the phone traveling, which is represented by the little blue car here, the conversation also travels from one cell to the other. And this is the change of the connection. Handoff ensures that the signal will not be suspended. Here we come to the threshold. It is important to choose the right threshold to make the communication continuous. For example, the handoff at point A can choose either threshold 1 or threshold 2. But the handoff at point B can only choose the threshold 3. Excel is used to simulate soft handoff model. Unlike the hard handoff, the soft handoff is make before break, which means the connection to the source base station is retained before the connection to the target one connected. In the Excel, we have set up some system parameters. We use these parameters together with the formulas listed in my report to calculate like shadowing, fading, and the receive power of base station A and B. And with this data, we get two pictures. The figure 1 simply shows the received power from base station A changes with the distance from base station A. The second figure is more important. Here we have two curves representing the received power from the base station. The red one means with distance from A increasing, the power received from base station A decreases. However, the blue one shows the power received from base station B are increasing with the distance from base station B decreases. Now let's go back to the slide. Here we come to the other part of this project, channel estimation. Channel estimation aims at overcoming the channel noise interference. It is designed for a class of anti-jamming techniques and methods. In this project, relay fading mean interference with the signal makes error rate increase. This is a simple structure of the encoding and decoding of the GSM channel. The out encoder and the out decoder are based on partition cyclic code. The inner encoder and the inner decoder are based on convolutional code. Here, noise is added to the channel. These are the amplifiers of out encoding and decoding, and these are amplifiers of inner encoding and decoding. These are the other parts. Now let's turn to the MATLAB to run this program. It is a little bit slow, so please wait a moment. Here we got this figure, and it is also shown in the slides. The blue curves show the ideal BER, which means bit error rate without relay fading. The blue asterisk tells us the original BER of relay channel with Gaussian interference. The red crosses represent BER of relay channel with Gaussian interference after the channel encoding and decoding. As we can see, after the SNR, which means the signal noise ratio is bigger than 1 dB. The error rate of the red cross is slower than the blue asterisk, which means the BER here is improved by the channel encoding and decoding, and the data is shown in this chart. Here we come to the conclusion. With the error rate decreasing, the threshold of cellular communication will be also decreasing. Then the receive power will be lower, which means saving the power consumption of both mobile and base station. On the other hand, there will be less unneeded handoff. In a word, the channel estimation with the method of encoding and decoding will in some degree ensure the continuity of signal and improve handoff efficiency. I really appreciate Professor Wu for his patient and diligent guidance, and thank you for watching.